All right. So I'm not sure. There's a new message queue that I just saw today on Reddit that's called Blazing MQ. The I'm going through reading the docs like I normally do, and I found this really interesting quote on Blazing MQ, which talks about a pattern I don't see messaging people talk about very often, which is just request response, like what we do with HTTP all day long. And so this tool, written by Bloomberg, which has some really interesting things. I'm kind of interested to watch it, but they talk about doing request response over a messaging based platform. That kind of got me talking to Chris over text message, and we were talking about request response, MassTransit, and I couldn't remember the last time we had kind of gone over that feature set of MassTransit. So you don't necessarily have to wait for some new message queue to come out to start using this.
Yeah, so way to jump right in. I mean, it's interesting that Bloomberg is, when I think of Bloomberg, I think of the old green screens that used to sit on the stock traders terminals. And, early in my life, I actually sat with those terminals on my desk and had a Series 7 licensed trader next to me that I was working trades for. So, I mean, my history with Bloomberg goes way back. So when I think of the kind of
Mm-hmm.
things they're passing around, it's a lot of data distribution, a lot of financial stuff. So I get that they're making their own message broker. But keying in on the request response specifically, it's interesting how they've tuned that into their engine, and yet we've been doing it all day long with RabbitMQ, Azure Service Bus, these other solutions, with great degrees of success. I mean, they're fast message brokers, and when you compare it, we're not going to hit any Tech Empower benchmark of like maximum requests per second that you can get with like the highly optimized .NET 7 or .NET 8 stuff that they're coming out with, because they are just grinding every little last morsel of performance out of that. But again, just like with the database transport, it's good enough. I can do
Mm-hmm.
1,000 requests a second. I can do 3,000 requests a second on RabbitMQ, and that's plenty for my business use case. I'm not running Reddit, so
Yeah.
I don't need to do that.
But yeah, so after talking with Chris, I started to implement this at MessageAid, where I wanted to talk to an agent that's running out in the cloud, and I want to talk to a specific one, but I want that request to be durable. So if the agent's down, if it's being rebooted because it's being upgraded, I don't want to deal with the transient nature that I would have to do with HTTP requests. So instead, I have a queue for every agent that's out there, and I simply put the request on the queue. The agent can pick it up and respond back when it's done. And that removes just a whole raft of otherwise error logic, retry logic that I would have to implement on top of asynchronous HTTP. And so today, I'd like to just walk through some code with y'all and talk about implementing request response.
Yeah, so let's do that. So I have a couple of different projects here. I created one very simple one, and we're going to try to do this with two of us on the code. But again, these samples have been out there. We'll just kind of go through it, and I'll try to keep the code up high so it rises above Drew's head. Yeah,
I can feel
exactly.
the bits.
That's right. So I've created two different message types. So when we talk about request response, what are we talking about in messaging? We're talking about, and we've talked about this before, putting a message on a queue. A consumer is going to consume that message, and then the consumer is going to put a message on another queue that will be picked up by the original requester. And MassTransit has a request client to do this. So here's my consumer. It's my account consumer, pretty exciting name, and it's going to have a get account balance message in it. Now the message is super simple. It's get account balance with an account number. No password, no anything. Just give me any account balance. I don't really care. And then the response to that is the account balance message, which has the account number, a timestamp of when that balance was good, and then the balance itself. Pretty simple, not a whole
Mm-hmm.
lot to it. And to run that, I have a simple account controller that is using the iRequest client for get account balance. It's
And that's in the MassTransit namespace, right?
yes, it is right there. And it's a very simple method. I got a getter. I'm going to pass it an account number. Call get response. Done. So if I run this, and assuming it runs, it ran a second ago, so it should run again. We're going to do the usual swagger, and I'm going to say, hey, I have account number 12345 Do I have a balance? Why, yes, I do. And my balance is $123.45, which is very similar to my account number. And it was quick. We didn't time it, but nobody noticed.
Doesn't it time it in the?
So it does. So that's the basics of the request. You know, I have a controller. I use the request client. Oh, does it? I'm not in Postman. I'm in Swagger. So I don't know if it does or not. Yeah, I don't see a timing, but that's okay. But yeah, so very simple thing. I take a dependency on this in the account controller, and I make my request.
And so, Chris, why is the T doesn't match the object on get response?
Mm-hmm.
I'm sending a request.
Correct. So
the get response is the type of the response I'm going to get back.
Correct. So the iRequest client, the first T is the actual request type that is being sent.
Mm-hmm.
And get response is where you specify the response type that is coming back.
Mm-hmm.
And as far as configuration of the bus goes, I made this very simple. I didn't even put a transport in it. I'm just using in memory, and I have an add consumer. There's nothing else to configure. I'm not configuring the request client. I'm not doing anything special there.
Oh, nice.
Yeah. So let's tease this up a little bit. Let's say that if context.message.account number equals 999, well, then we are going to return context.respond async new account not found. And we'll even put the account number in there equals context.message.account number. So we'll create a new message type for this, which will just be record account not found. And we're just going to take a string account number. And then we will return that instead. And I am going to go fix this because I am sick of that nullable warning on that. So
double equals.
Oh, right. The double equals. Yes. I've been doing a little bit of SQL lately. I don't know if you guys know. I've been working on this database transport. It doesn't like double equals for some reason. So since I created a primary constructor, I don't need to init this, and we're good to go. And so what I just did is I said, hey, if the account number is 999, return account not found.
But so how's that going to play out on the other side? Now there's two types.
Oh, yes, that's right. So let's go back to the controller and say, I also want to get account not found.
So then how do I know which one it is?
Well, now I have a couple of options here. I like this one because it's prior to like the really silly pattern matching. Response account not found. So if it's a response not found.
Can you scroll the code up?
Oh yeah, is it under your brain? Yeah.
Mm-hmm.
So basically now I'm specifying two types in the get response, and I'm saying if the response is not found, I'm going to return a not found. And I will just put account number. I think it's not found. Okay. Yeah, so now I will return not found if it's not found. And otherwise, I'll return OK.
So just because you said it, is there a way to do this with the pattern matching?
There is. You can actually say response, and then you can say switch. What is it? I could do like return, response, switch. What is it? I think it's like account balance, comma. I think it's something like this. I can't remember. Balance, okay, balance. Or I could say not found. Was it account not found?
Mm-hmm.
Not found. Not found. Account number. Oop. Ah. Oops. Don't type that password. And then we would probably need like a default one because I think the world likes a default. And
Because .NET has open enums.
we'll just throw an exception saying ouch. Okay, so
Quick question.
yes, sir.
Curious. Oh, okay, that's why. Does it then also work with the the syntax of if response is type new name?
Mm-hmm.
You know, the other version of the pattern matching?
Oh, I don't know. Probably. I mean, it's pattern matching. I'm sure it does. I just don't know it, so
Okay.
I don't use that syntax. But yeah, you could say is.
Mm-hmm.
But so this is just
Okay.
using a destructured type. So
Yep.
now when I run this, it will. Well, it's already running actually. So we will just kill it and run it again. And when I go into Swagger, I will say get. I will say try it out. I will say 999, and I should get a 404 not found. Yep, error not found. Account number 999 not found. So yeah, so now I can support the different types. Boop. Right there.
Well, that's cool. Okay, so
Yeah.
I can handle multiple types. What happens? And in this case, we throw an exception if the types don't match. So if we introduced a third type, then it would hit the fail if arm bracket. Or
It,
does MassTransit do something?
well,
Because it's
so
not one of the T's.
okay, so that's a great question to bring up. So
Like just
if
take
it's
out the account not found bit.
yeah, so if I take out account not found and I hit well, obviously, I mean, I don't even need to change that code, but let's say I take out the account not found and I send it a 999. It sure is taking a long time. I wonder what's happening. What could it be? Oh, well,
Mm-hmm.
I don't have debug logging turned on. But the reality is it responded with a not found, but it's not supported.
Mm-hmm.
So the message gets discarded because it's not handled by the response client because you didn't tell it to.
Mm-hmm.
And so it's just going to time out
Okay.
because I didn't get a response. So how do we handle that? You might ask. Well, let's handle that. Let's say if account number is 99 and context.isResponse accepted, account not found, now I can do that.
So if the
So
requester,
right. So let's split this into two ifs. So if the requester accepts that type,
so how does it know?
because MassTransit encodes all the accepted response types in a header when the request client sends the request.
You fancy.
I know. So now we can say you don't support my type, so you must fail. So now I'm basically throwing an exception, which is actually going to fault back at the request client. So now if I come in here and do this again and I do the 999, I should get an immediate response, but it's a big nasty request faulted. You don't support my type, so you must fail. 500 server error.
So if we go back to the controller,
See?
so at what is that, like line 22, I'm going to get an
Yep.
exception.
Yep. And I think that's exactly the line we got it on. So you can see in the logs, here is the fault that the controller threw,
You're
the
going to have to bring
exception.
it higher.
Yeah, I will. So if we look in the logs here, you can see the fault that was thrown by the consumer,
Uh-huh.
the application you don't support my type, and then the ASP.NET Core Developer
Mm-hmm.
Middleware says an exception occurred This says, it's got the whole call stack, but by the
Yeah.
time we get back to the controller, I think you're right, it's line 22 in the controller.
Okay, that's cool.
So because the request client also handles faults and will also
Hmm.
throw a timeout exception if the timeout is exceeded.
Now, knowing you and how long you've worked on this thing, how do isn't it, I'm guessing there's a way to handle faults in the configuration of the request.
What do you mean?
Like, is there a separate argument after the get response where I can like tweak the request on
Y-
line
you
25?
can, yeah. So you could say context, fat arrow, context, dot, and you can add headers. You can get access. You can set the time to live to request timeout. You can add all the middleware in the world you want to the response pipe. So, I mean, anything you wanted to do, you could do there.
Interesting.
You can get access to the request ID, which is automatically generated by MT. You
Hmm.
could set the time to live, which defaults to the request timeout of 30 seconds. So this is an important point. If you're sending commands that you absolutely want to happen at some point, you need to set the time to live equal to something bigger than 30 seconds, like days or whatever.
Okay.
Because by default, time to live is set to the same value as the request timeout, which defaults to 30 seconds.
Okay.
Uh,
So where do I set the request timeout? It was just another property on context.
um, I think it's just let's see, you can pass a cancellation token. I could also just say timeout colon request timeout after, I could say 30 seconds. And I want to say that this is probably callback. Yeah,
Oh.
because I don't know what order the argument's in. There's a
Yeah, yeah,
bunch of
yeah.
nullable arguments. So, but
Okay.
yeah, so then I could say, well, I want a timeout after 30 seconds, or I could say timeout after 5 seconds. I mean, it really doesn't matter.
Is there a way how do I know if I timed out?
You will get a timeout exception. So let's do this.
But Chris, exceptions are expensive.
No,
We
they're
should
not.
be doing control logic on exceptions.
Exceptions aren't that expensive. So let's set our request timeout for 5 seconds.
Uh-huh.
And now we will go into here and we'll run it. And then if we go back to the Swagger, when we do the request, it's going to time out because there is no consumer.
Hmm.
And so we'll see that timeout exception. Because here previously we got the request fault exception because the consumer fault gets propagated back as a fault. This time we get the request timeout exception.
Okay.
Yep.
And so then I put a try catch around it.
Yep. Handle it the way you would.
I want like a timeout. So I could switch on timeout.
Okay. So this is very basic request response. This is requests from controllers. Let's escalate things a little bit. Let's turn it up a notch. Let's say you have that what your comment earlier about I want to send the request
Hmm.
and I'm going to get a response eventually, but I don't care when it is because I know the work's going to be done.
Yeah.
So request clients are, I guess the word is ephemeral. They're meant
Hmm.
to be used in like controllers, things like that, things that don't live very long. In some cases, you can use them in consumers, but think about what you're doing. If you're making a request to a consumer that's making a request to a consumer, and so on and so on,
Hmm.
you're basically building a nasty stack of RPC calls again,
Yeah.
which we know how well that turns out when you use HTTP.
Hmm.
So generally what people do, and I'm going to jump to another project now. I apologize for doing that, but I don't have this coded in here, and I already have it in our web application factory sample that's on the MassTransit's GitHub. So when you're ready to move your request response to the next level, you use a saga.
Okay.
Because sagas have their own implementation of request response that does not use the request client, but it uses all the same semantics as the request client. So it behaves exactly like it. So for instance, I have an order state machine here which wants to validate an order. And so I want to create that request with the validate request. Notice I give it a timeout of 0 because I know it will eventually complete. I don't have to worry about it timing out because I know that message will eventually be processed.
Okay.
And
And so,
then,
And so on line 25, are you configuring the request client that's being used?
I'm configuring the request that's part of the Saga, yes.
Okay.
It's not, it doesn't use the request client. The Saga state machines know
Mhm.
how to do requests to consumers, whatever, other state machines, anything.
Mhm.
Because like this state machine actually handles a request. When it gets an order status requested, it responds with the order status.
Gotcha.
So, but to your point, you want your timeout. So the validate request has a completed, a faulted, and dun
Wait a
dun
second.
dun.
Where's show me validate request again? Show me send the
Show me send a floor.
yeah.
Validate
Where's that
request.
at?
Validate request is defined. I'll put a bunch of character turns. Validate request is
Oh,
stored right there. And so I'm defining a request. It's on the state machine. This is the command, or this
you
is the request
sneaky
type,
sneaky. There's
and
a
this
whole
is the
new thing.
response type. Yeah.
Can, can it do multiple response types?
Of course it can.
Heck yeah, brother.
Order not found. Yeah, sure. Validate request too. Look at that. Yes, it does support multiple response types.
All right.
I think I give you up to 3. I mean, come on. I don't need to like
No,
do
that's fine.
16 or whatever. But
Well,
yeah.
and you're giving me the timeout faulteds.
Yeah.
So,
So the other thing you can do is here is you can actually say on validate request timeout expired.
mm-hmm.
So because MassTransit, it just schedules a message for, the request client just uses the call stack because you're
Mm-hmm.
awaiting the request client. The state machine, because it's obviously a state machine, it's using the scheduler to schedule that timeout for that request.
Okay.
No. But I
So do
generally
I have
don't
to have
use that.
something else running then?
If you're using a broker that has delayed exchange support, which most of them do, then you don't have to install a scheduler, but you do need to enable it with I think it's use delayed message scheduler.
So in
Um,
Rabbit.
I don't think it's in the worker. I think it's in the API because that's where I think the state machine is. Yeah, I don't know why it's not in there. Should be.
But so I
Oh,
need
because
to.
I don't use a timeout because I trust that it's going to complete, which is why I don't need the scheduler with this
Gotcha.
sample. But
But
yeah, so
otherwise, you would use the delayed stuff in Rabbit,
right.
or
If I needed to use the scheduler, I would use delayed message scheduler and be done.
and so Azure has that, right?
Yeah, Azure actually has a really nice one. It's use Azure. Oh, well, I don't have Azure reference in this
Yeah, yeah.
project. But yeah, it has one that will actually support cancellation of scheduled events, but
Mm-hmm.
not. It's weird with requests because of the way the GUIDs are generated. So I generally just use a separate schedule in a state machine if I'm using Azure rather than
Mm-hmm.
using a request timeout. Because I can't cancel it with Azure if I use the request client. Whereas if I use schedule, which is another state machine primitive, I can do it that way. Just like you have that one, I could also just schedule, you know. But again, we're not really talking about that today.
No, but it's just helpful to see.
Yeah, but I could schedule a validate order. That's just one thing. And then I could actually schedule that using the scheduler and then cancel it and just do like a dot schedule.
Okay,
Yeah, and then I just pass. I think it's just
that's
VR2.
interesting.
Yeah, so the scheduling stuff, it's in the docs and
Yeah.
there's other videos on it. But yeah. But yeah, so this is how you would do a request from a state machine. And the nice thing about that is the state is stored in the Saga repository, so you're not eating up a call stack. You don't have something waiting
Mm-hmm.
on a thread blocking like the request client does. And you know that eventually that message is either going to be a fault, so you're going to get the faulted. You're either going to get the timeout, which I don't schedule a timeout, so I just put that in there just to kind of show that you could do it.
Mm-hmm.
Or you're going to get completed. And there's like a completed 2, completed 3, depending upon if you do the multiple response types.
Gotcha.
The compiler isn't super smart to let me like use the name of your message here. That would be too cool, but it doesn't. So no dynamic property types. So, but yeah, so a lot of great ways to do request response. They're also, to unit test them. I think I covered this. This isn't that sample web application factory, but in this case, like the state machine. Remember we said that it
Mm-hmm.
uses that validate? Well, I don't have that validate consumer. That's in a separate worker over here.
Yeah.
My validate consumer is in a separate worker that I'm not testing. So in this case, I just add a handler to say the order validated so that the state machine is actually able to do its thing. And then when
Got
I
it.
run the test, it will actually validate with the state machine.
Hmm.
Yeah, so.
Yeah,
Yep.
I've been using the heck out of the test harness today,
Oh,
and
so yeah.
man, that is super nice.
So this is the test harness for that very simple project. They're just a simple request
Hmm.
response. I just add the consumer and I just call get request client,
Hmm.
get response just like you do. And when I run that, it just does its thing. And you can see it does all the thing. It configures the bus, runs localhost, and I even configured the telemetry listener so I could see like how long it takes to send and receive the request.
How did you do that?
So in the test harness, before you call add MassTransit 10 harness, you can say add telemetry listener, and all it is a
Mm.
text telemetry register that generates that table.
And
So you
that,
can
is that a mass transit thing or is that an OTel thing?
it's a mass transit thing, but it's listening to the same thing that OTel
Hmm.
listens to get the telemetry data.
Fancy.
Yeah, so it's kind of cool. But you can see all it is doing is we sent a message we publish a message. So the request client publishes by default. So we publish
Hmm.
it, the type get account balance. We received it, we processed it, and then we sent the response to the bus, which then received it and processed it. And that's that request client because it sits on that bus endpoint.
Right on.
Yeah.
Well, cool, man. Request response, NMT, and I think you've done some testing where like it's not exactly slow. Just to reiterate.
Yeah, no, I've in the Mass Transit benchmark project, which is in the Mass Transit repo. I think I've tested it. With RabbitMQ locally, I get like 2,500 a second, something like that. It's plenty.
Yeah. When the database is taking 200 millis.
I know, and that's the thing is that's just an immediate response. Give yourself even a 4 millisecond response time from your database, and that's 250 a second.
Hmm.
So yeah, it's plenty fast for most use cases. But again, your mileage may vary, and that's why people have things like gRPC and stuff as well when they really need that higher volume.
Yeah. When it's more about speed and less about durability.
Exactly. So yeah,
Well, cool. Well, thank you, Chris. That was a nice little whirlwind tour.
yeah, very good. Well, hope you enjoyed it, and we'll catch you on the next bus stop.